Hello everyone. Today we are going to see a device that is called Fresnel Biprism, and by using this Fresnel Biprism we can show the phenomena of interference. So see here in this topic what is the Fresnel Biprism and how we can obtain the phenomena of interference, and by this experiment we can also determine wavelength of monochromatic light used in the experiment. So see the whole procedure, how the phenomena of interference is obtained, and finally wavelength of monochromatic light can be used. So see carefully, this is Fresnel Biprism is a device or instrument. So we may say it is device, right? Device to produce two virtual coherent sources. We are knowing that to show the phenomena of interference, coherent sources are needed, and coherent sources that produces light of same frequency and constant phase difference, which is a compulsory condition of interference pattern. So Fresnel Biprism experiment, two virtual coherent sources are produced. So let us see very carefully what is this Fresnel Biprism. Fresnel Biprism is made by two right-angled prism. Two right-angled prism, base to base, like this diagram here. Two similar right-angled base prism joint base to base. So like in the diagram, prism number 1, prism number 2, in such a way that this angle, which is obtuse angle, is of 179 degree. We are knowing sum of the all three angle of a triangle is 180 degree. So 179 is this, and it is both half. 1 degree means half degree this and half degree this. Half degree are 30 minute each, forms biprism. Bi means two prism. So prism number 1, prism number 2. So here this one angle, obtuse angle 179 degree, and acute angle half degree each here in this case. So see once more, phrase 179 this is now. So see once more, Fresnel Biprism is device to produce two virtual sources made up of two right angled prism joint base to base, like the diagram. The angles are like this, and phenomena of interference pattern we can obtain, and by that ultimately we can determine the wavelength of light used in this case. Since we know that fringe width beta can be obtained by formula, that is capital lambda capital D by 2D, where symbols have their usual meaning. here in it. Fringe width beta. By this formula, one may write wavelength of monochromatic light lambda can be given as beta 2d by capital D. Let us see this equation here, equation number 2. Now before go for the determination of wavelength of monochromatic light, let us see how interference pattern obtained by Fresnel biprism experiment. So for this arrangement of this, let us see here in the diagram. It is Fresnel biprism here. Let this is the source of monochromatic light. Yes, in the experiment we are using sodium lamp. As a source here. So the ray of light from the source here falling on biprism. By this rays, see very carefully, take a dotted line and treat it as a screen where interference pattern will be analyzed. When monochromatic ray of light is fall over the biprism, right, see the direction of rays. First ray, and there are two. First right angled base prism, second right angled base prism. See very carefully. From the bottom surface of this ray of light, one ray becomes parallel here, and from the lower side of first surface it moves on this side. So first part produces light from here. Suppose this point is B to here, point E in it. Now when one proceed this ray backward, it seems to come from here, and one virtual source S1 is produces here. Now see, this ray of light fall on the biprism, and after refraction this shows parallel here, and from upper surface of second part of the right angled prism refracted in this direction. So it moves from, let's see, to point E, right? Let middle point treat as a O. When again this rays proceeds back, it seems to come from another point S2. These two virtual sources, S1 and S2, two virtual sources S1 and S2 behaves as a coherent sources here in it. Let distance between both is denoted by 2D, and capital D denotes the distance between virtual sources and the screen here. See very carefully, The first part of biprism, the ray of light is from here to this, B to E, and from second part A to C. So common area is B to C. B to C. B to C means C by this line. So phenomena of interference pattern obtained between C to B, or we may say B to C. Eyepiece is here to see with the cross wire. This eyepiece is the telescope used to see the interference pattern here. The interference fringes form same like as the interference pattern obtained in case of young double slit experiment. Center fringe is bright, followed by dark fringe, again bright fringe. So alternatively bright, dark, bright, bright, dark, bright obtained in field of view by this experiment. Clear? Now see one more thing very carefully here in it. Carefully in it, by this experiment, we have to determine the wavelength of monochromatic light, that is the sodium light, and it is given by the equation number 2. This wavelength lambda is equal to beta 2d by capital D, where beta is, we know, fringe width, 2d is distance between two virtual sources, and capital D is a distance between virtual sources and screen. So for determination of lambda, we have to determine the three terms. First, determination of 2D, determination of beta, and determination of capital D. So first of all, we are going to see determination of fringe width beta. So see the process how the fringe is obtained, fringe width is obtained. So for that, come here in the experiment, all the apparatus is set up and interference fringes were formed, bright and dark fringes alternatively, and eyepiece is brought at a center fringe, and cross wire is fixed at a center fringe, and position is noted. That is the position of center fringe is noted. Then it is noted, suppose it is x1 in centimeter. Now this telescope is moved either upward and downward, and up to the number of 20 fringe approx. 20 fringe it moves upward, and again position of fringe is obtained. Position of 20th fringe. Suppose it is x2 is equal to in centimeter is noted. then the distance L can be obtained by obtaining x2 minus x1 and fringe width beta can be determined by knowing this L, that is the x2 minus x1 by number of total fringes that we have taken 20. So determination of beta can be obtained by this formula. Third. So determination of beta is clear, seen the formula. Then now it is required to see the determination of distance between two virtual sources. Second, determination of distance 2D between two virtual sources. See how it is obtained. To see this, see very carefully. Let it is a position of biprism here. Main source of monochromatic light is here. Two virtual sources are produces S1 and S2, right? And the distance between two virtual sources is 2D, which we have to determine. Clear it is? Now see, in this experiment, we use a convex lens to obtain the distance between two virtual sources. Let this is the position of convex lens of short focal length, around 15 to 20 centimeter is used for this purpose. We are also using the focal length of 10 centimeter also for that. So these two virtual sources S1 and S2 behaves as object and their image is formed on the screen. Let it is screen is here. Their image, suppose it is formed here. Image of the object. So keep position of lens at position L1 in such a way that the image of this is obtained clearly on the screen. See very carefully. In that condition, see that it becomes U, distance between object and lens, and it becomes V. Now with help of the telescope, by moving at both positions, noting the position of both and difference of both obtained here, suppose noted D1, right? And by magnification formula 1 may write I by O, D1 by 2D, size of image by size of object here is equal to V by U. This is equation number. Next equation number, that is equation number 4 is here. Experiment is done in one more way, one more part. The biprism is at same position. Main source is at same position. Virtual sources S1 and S2 which is produces both also belong at the same distance 2D as the first part. Now let this is a position of screen. Screen is at the same position as in the first part of experiment. Screen and distances between the two virtual sources is the same in the second part of experiment, no change. Only the position of this convex lens is changes in such a way. One, the distance between UV interchanges their value. The distance between second position of lens L2 and object becomes V, then naturally the image will formed on the screen at a distance of U, because U plus V is a constant here in this case. And at that situation, one more thing appear. Again the image of two virtual sources is formed here, and with help of the telescope moving and fixing the crosswire at the mid of both, the distance between virtual sources can be determined. Suppose now this time is D2 it is. This time it is obtained different from the first part of experiment. So again by using the formula of magnetism I by U, that is D2 by 2D behaves as object is equal to V by U. But V is here U and U is here V in this case. Equation 5. Now what we are going to do? We are multiplying equation 4 and 5. So D1 by 2D into D2 by 2D is equal to left hand side with left hand side, right hand side with right hand side. U is cancelled by U, V is cancelled by V. So what it's become? D1 D2 by 2D whole square is equal to 1. This implies that 2D square is equal to D1 D2, or 2D is equal to under root of D1 D2. See, this is a new equation obtained 6. So what done here? By doing this both experiment, by knowing the value of D1 and D2 and measuring UV in this case, the distance between two virtual sources can be determined. By the experiment, we are able to determine the value of fringe width beta and 2D. And now this is time to determine capital D, that is the distance between source and screen. In the optical bench, by knowing the position of monochromatic source sodium lamp and position of screen, we can determine the capital D easily. And by putting the value of fringe width beta, 2D and capital D in the formula, wavelength lambda of sodium light can be calculated. Clear? So this is the procedure by obtaining or determining wavelength of sodium light used or monochromatic light used by Fresnel biprism. So this is for the topic. Thank you and have a nice day.